basically we have a few of the principal elements of our system on display here, which is basically our evaporator jacket and our receiving carousels. Ideally, we'll have a feed tank up here where you would put your crude oil. You feed it through the system, hits this spinning top plate. You have this jacket, has a mylitherm running through it and controls the temperature setting, so you can heat this up to the boiling point of the molecules which you want to fraction off. It's falling through this evaporator jacket. These wipers on the outside are spinning, pushing the film that's falling down into what we call a thin film to ease the efficiency of evaporation. And then you have an internal condenser that's also hooked up to a circulator bath where you can control the temperature so that you can condense the molecules that you're evaporating. In the sense of concentrating THC, we would pass our crude oil through. You would get all your fats and waxes and general off product of winterization on your right residue flask, and your THC, your cannabinoids, flavonoids, terpenes, whatever you want to collect will fall off into your distillate. And you'll be separating anything from the colors, potentially pesticides, mold. So for example, this is a part of our toll processing gig where we refine CBD for European clients. So they might do a heavy alcohol extract and pull out a high yield, but it's primarily mud, we like to call it. It's 1%, 2% CBD. Basically feed this through the system, and depending on your parameters, you start pulling off your unwanted material. So in a first fraction, we go from the black to something that might be like this, orange, that is now 20-25% CBD. You put this material back into your feed tank, feed again, change your parameters to whatever molecules you want to pull out. And then next you get to a very clear, very clean oil. It's about as high of a potency as you can get. You can bring it to the point of 99.9% cannabinoids, terpenes, flavonoids, whatever you want to pull off and collect those. This is better in the sense that it's higher purity. Therefore, you have to use less material to, for example, infuse a product or create your dosing. And ultimately, it's a cleaner product without the waxes and any of the other unwanted material that's not specifically the molecules you're after. This sort of system, in fact, Chemtech Services, our partners in this business, are the North American division of UIC, and they are the founders of the science that is short path distillation out of Germany. Used in the petrol industry, fish oil industry, nutraceutical industry. It's basically used to separate whatever molecules you want, whether it's plastics for 3M, fish oil, or nowadays CBD. It's brought from the petrol industry primarily. That's where it really started. It's for fractioning off, you know, your diesels, your benzenes, different petroleums that you want to pull apart. Also used in fish oil industry to pick apart pesticides, other unwanted material. You can use it in the olive oil business to clarify your products. It's used in a number of products. For example, 3M will have a lot of their products distilled, their plastics, sheen coatings for microchips. It's just another way to pull out and concentrate whatever molecule for multi-purposes. And now we've brought it and made it useful for the cannabis industry. So aside from being a direct descendant of the founders of the entire science, we have a number of aspects of our systems that make it quite competitive compared to other systems out there. One of the big ones would be our use of hot oil circulators. So you cannot see it on this system with the parts we have, but ultimately the hot oil baths that control our evaporating and condensing temperatures, you can set and have those be retained at your setting to 0.1% of that temperature setting. And that will keep your consistency in your distillation, allow for the product not to end up with striations in the end or spillover of molecules that you don't want. Another one is our evaporator jacket surface area. So when we say this is a KDL6, that means the evaporator surface area is 0.06 square meters. And we have that as an equal surface area on our condenser. So say you're passing your molecules through and you have 100% efficiency in your evaporation because of the same surface area, 100% of that those evaporated molecules can be condensed on that condenser, and therefore you're not losing anything to the vacuum pump or again going into your residue bath because we have the balance of being able to pull those molecules over. Proficiency of design, our connection with Leibel vacuums and the high precision parts local manufacturing with the glass, the metal, and total fabrication in Lockport, Illinois. And we like to say we make a very great system. And our chemical engineering team is building anything from these small laboratory systems to the billion-dollar systems you see used by ExxonMobil, DuPont, etc. Pricing. So our entry-level system, KDL4, is coming in at just over $57,000, and then we move up to our KDL6, which is about $112,000, and then we get to $125,000 for a stainless steel version of our KDL6, and then our big boy, our KDT, partially PL controlled, comes with all the bells and whistles as far as hot point circulators, cold trap circulators, and that's coming in at just about $128,500. And those are our 4 standard units, and then we do a number of customizations above and beyond that. You could have a system that runs a 0.5 liter per hour. You could have a system that's running multiple tons per hour.